Hey, ladies and gentlemen. So, in case you missed it, so in class on Thursday, we're going over the electron excitation POGIL, or how energy and light affect the electrons. So remember, we've been talking about protons and neutrons now and electrons. Now we're just focusing on the electrons or the negatively charged subatomic particles. So colors of light happen all the time. We see them all the time. We wear different colors. We see different colors, all that good stuff. Well, to be more specific, we can talk about how different colors come from different elements and how they interact with, or their electrons interact with light or energy. So when light or the sunlight interacts with different elements, we see different colors. All right. So each thing is different. Each element is going to be different that we see. So we take a look. So in question 1, it does say to trace the arrows, and I'm just going to trace the first one just because we don't need to do all of them together, but you guys get the idea. Just color the arrows in the different colors. So if I were to do red and violet, then we got them both, and I know I messed up on the connecting, but for all intents and purposes, we can see that there are 2 different colors, just like there are 2 different lines. It says in question 2, what happens as light passes through the prism? So light passes through the prism. We see that white light separates and it turns into all of the different colors. So we see every single color, not just white light anymore. So it separates into the pieces or parts that make up white light. All right, and I'm not going to go through all of them because you guys can do that. But okay, we see that it separates into its parts. And so we have this giant table over here. And so we're going to use this table over on the side right here. We're going to use this table to explain some of this stuff down here. Right? So to explain these numbers, the longest and shortest wavelength, the largest and smallest amount of energy. I do want to go through one more together, and it's which color corresponds to the longest wavelength. I want to go through 6A, just because I know there's sometimes some differences. All right, if we take a look at 6A, so which one has the longest wavelength? Hey, we're just looking for the largest number on the screen. So if we look, 740 is the biggest number under the words wavelength range, right? Which means that the one that has 740 or reds has the longest wavelength, all right? So we're not looking at which one is the largest difference between those two. We're just looking for which one has the biggest number, right? That's all we need to look for. And if we keep going, you guys should answer questions 1 through 6, A, B, and C, and then check your answers. Make sure you get them right with the answer key, and then keep going. So then if we keep going, we look here, and the first thing we need to do is color in these lines right here. So we color in the blue-green, we color in the violet, we color in the blue-violet, we color in the red. All right, so we're coloring in all those things. Just the white blank spaces in between that gray area. These are called emission spectra, and that's because they're emitting only the colors that hydrogen would present. So hydrogen presents violet, blue-green, and red. All right, and we can look, boron does violet, blue, blue-green, orange, and red. So it says for hydrogen, we need to list the spectral lines and their corresponding wavelengths. So we'll do 8 together, and we look, we have violet, and violet corresponds with the wavelength 410 nanometers. Right? And a nanometer is 1 times 10 to the negative 9 meters. So really, really, really tiny. All right? Or it might be 1 times 10 to the 12th, if I remember correctly. All right? one or the other. It's really tiny numbers, okay? The next one is blue-violet, and that is 434 nanometers. The next one's blue-green, which is 486 nanometers. And the last one is red at 656 nanometers. All right, so we have all four of those with their corresponding wavelengths. Now in question 9, it's talking about the same thing for boron as we did for hydrogen, making sure that you're picking 3 of those colors in any of the wavelengths from those 3 colors. Questions number 10 and 11. I want you to look back at model 1 to help you with your answers for questions 10 and 11. All right, in case you have any issues, look back at those models to see, all right? Number 12, right? It says they emit the same. Remember to use evidence here, okay? So come up with some sort of evidence from model 2. So something about model 2 that tells you yes or no. Use some evidence or some data, something given to you. All right. And I did really want to go through these questions right here. And it says circle the appropriate word for completing those sentences. So protons and electrons. Remember, we have our negative charge and our positive charge. And if we remember, we talked about this before, but opposites attract. So this one's going to be that they attract to each other because they're opposite charges. Remember, those electrons want to be as close to the protons as they can, and they want to get closer and closer. And if we know that they attract, the closer those electrons are to the nucleus, the more attraction they have, because the attraction gets stronger as there's more electrons closer to the nucleus. So that's why we get smaller as we go across the periodic table, because our electrons and our protons are getting closer together because there's more pull or attraction between them. And last but not least, those last 2 questions, as they move from an energy level close, so closer to the nucleus, as they try and get farther away, remember they're moving away from the nucleus, not forever, but they're moving away. We need to put energy in. To push those electrons away, we have to put energy in to push them, all right? If we have that energy leave, those electrons are going to fall back to where they were. Right? So we're going to lose energy to get those electrons to go from far away to close together. All right. All right. So now I want us to read through this real quick, and we're going to read through it together. We're going to talk about it. So it says Niels Bohr modified Rutherford's nuclear atom model. So the one we've been drawing, that Bohr model, was designed by Niels Bohr, which is why it's called the Bohr model. And it explains how light interacted with the electrons in the atom to produce these spectral lines. So it tells us more specifically where the electrons are and how they interact with energy or light. In his model, it included the electrons orbiting those rings, orbiting the nucleus at specific energy levels or specific ring numbers, right? We have 1, 2, 3, or the first orbital, the first energy level holds 2 electrons maximum. The second and third ones hold 8, so on and so forth. The electrons absorb energy from different sources like electricity or heat. And when they move from a lower energy level, like this one does, to a higher energy level, that's when they absorb that energy or gain that energy. When the electrons release the energy, those electrons move back from that higher energy to the lower energy, called from the ground to excited, and then the excited state back to the ground state. So this first question says, is energy absorbed or released? So if we're moving away, we got to think, if we go away from the nucleus, do we absorb energy or release energy? So go ahead and answer that question. All right. answer that question individually, talk to your neighbors, and then go check the answer key up at the front, see if you got it right. All right. Make sure to explain your answer. Okay. Don't just write one word answers here. It is an explanation. So, why are you saying it absorbed energy, or why are you saying it released energy? All right. Make that decision. Down here in model 3, this is one that gets a little bit trickier. All right. So, let's go through this together. In model 3, what you need to do is decide where is the electron starting. So where is the start of that electron is going to be the end of the arrow, not the point, but the end. So if we follow along, we can see that this one ends at n equal, or starts at n equals 6. So we put n equals 6, and then we can see that it goes to the tip of the arrow, which is down here at n equals 2. So then we go say n equals 6 to n equals 2. You need to do that for the other 3 and decide where they're starting and where they're going. Right? The next thing we need to decide is, are we absorbing or are we releasing energy here? So is energy going in or is energy going out? All right. So decide that based on the arrows that you see and where the electrons are moving and the energy you see going in or going out. All right. Last thing you need to do, and this is more based off of model 2, you need to decide which of the 4 is each color. So you need to decide which one is violet, which one is blue-violet, which one's blue-green, and which one's red. So there are 4 from hydrogen way up here. There are 4 colors, and those 4 colors of hydrogen correspond to our 4 Bohr models. So again, we have violet, blue-green, and red. Pick which one goes where, and make sure you know why you're thinking that. All right, and then answer the 3 questions below on question number 19. So B, C, and D. Once you do that, we've actually answered question 19 and question 20. So once you've done that, you've answered 19 and 20. So now we just have question number 21, 22, and 23. When you get to questions numbers 22 and 23, we need to remember how many electrons hydrogen has. All right, because that's going to be super important in our ability to answer these 2 last questions. All right, and if we don't remember, we can always look it up on the internet, or you can ask a neighbor, ask a partner, right? But remember, hydrogen is our first element on the periodic table, so we should be able to tell me how many protons it has. And if you can tell me how many protons it has, remember the protons are the same as the electrons. So once you make that decision, you can answer questions 22 and 23 on your POGIL. And when you're done, that's it. And then you can turn it in. If you have any questions, let me know. All right. Email me and I'll be happy to answer them at some point over the weekend. All right. Have a good one.